Good morning friends, I am Professor Prof.Dhananjay. Today we are going to start design concept in limit state design. Methods of design. Reinforced concrete structure should be so designed that it fulfills its intended purpose during its intended lifetime with adequate safety in terms of strength and stability. Second, adequate serviceability in terms of stiffness and durability. And last one is reasonable economy. Thus, all structures must be designed to be safe, serviceable and economical. Reinforced concrete members can be designed by one of the following two methods. First method is the method of theoretical computation using accepted theories, procedure approved by the code of practice like IS456. The methods of experimental investigation on the models of full-size structures or the elements. Commonly used structures are designed by the theoretical methods. The following design methods are used for the design of reinforced concrete structure elements. First method, the working stress method, that is WSM or modular ratio method. Second, the ultimate load method or load factor method, and last one is a limit state method. So one by one we are going to see what are these three methods. First is the working stress method, that is WSM. This is traditional method of design in which the method is based upon the linear elastic theory or the classical elastic theory. So here is you can see the curve. Okay, when we are going to test the bar, so elongation of the bar, that is strain, and the stress. So here this method is based upon the linear elastic theory or the classical elastic theory from this graph. This method ensures adequate safety by suitably restricting the stresses in the material, that is concrete and steel, induced by the expected working load on the structure. The assumption of the linear elastic behavior is considered justiciable. The ratio of yield stress of the steel reinforcement or the cube strength of the concrete to the corresponding permissible working stress is usually called the factor of safety. The WSM, that is working stress method, uses the factor of safety for concrete is 3 and for steel is 1.8. The various demerits and merits of the working stress method. So first we are going to enlist what are the various demerits of a WSM method. The WSM does not show the real strength nor gives the true factor of safety of the structure under the failure. Means under the failure you cannot get the true factor of safety in the WSM. The modular ratio design results in a larger percentage of the compression steel than that gives by the limit state design, thus leading to uneconomic design. Because of creep and due to this uneconomic design, the section size is very high in a WSM method. Because of creep and the non-linear stress-strain relationship, concrete does not have the definite modulus of elasticity. The WSM fails to discriminate between the different types of load that act simultaneously but have difficult uncertainties. And there are various merits of the WSM method also, and these are the various merits of the WSM method. The WSM has an advantage of its simplicity, both in a concept as well as in an application. The design usually results in a large sections of the structural member, and due to this large member of section designed by WSM, better serviceability performance, less deflection, less crack width under the good working load, because due to the heavy sections of the large depth of the sections, so ultimately that you are going to get the less deflection and less crack width also. WSM is only method available when one has to investigate the reinforced concrete sections for the service stresses and for the serviceability states for the deflection and the cracking. So these are the following merits of the WSM method. So next method we are going to say that ultimate load method, that is the ULM. This method is also known as the load factor method or the ultimate strength method. In this, we make use of the non-linear region of stress strain curve of the steel and the concrete. The safety is ensured by introducing the load factor. The load factor is the ratio of ultimate strength to the service load. Following the demerits of the ULM, the serviceability criteria is not to met because of the large deflection and the cracks in the section. Already we have seen in WSM, when you are going to reduce the stresses in the material like concrete and steel. Ultimately, the size of section you are going to get, that size of section is very large, and that's why there is advantages in case of the deflection and the crack in the deflection in the crack width. Here, in ultimate method, when you are going to, instead of reducing the stresses in the material, we are going to increase the load. We are going to give the load factor, and due to that, the section sizes is going to reduce. But in the serviceability criteria not met because of a large sections and the cracks in the section. Even though the non-linear stress strain behavior was considered the sections, but the non-linear analysis of the structure was not carried out for the load effects. Okay, for the load effects they are not going to calculate the non-linear analysis for the load effect. Thus the stress distribution at ultimate load was just a magnification of the service load by the load factor following the linear elastic theory. So ultimately there are some merits of the ULM also. The ULM max is possible to consider the effect of different loads acting simultaneously, thus the solving the shortcoming of the WSM method. Load factor gives the exact margin of safety against the collapse. This is the merit of the ULM. The method allows to use different load factors for different type of loads and the combination thereof. The failure load computed by the ULM matches with the experimental results. The method is based on the ultimate strain as the failure criteria. The method utilizes the reverse of the strength in the plastic region. And last and important method is a limit state method. And generally nowadays this method is generally used, that is limit state method. So we are going to see now what is limit state method. This philosophy is an advancement over the traditional design philosophies like working stress method. It considered the safety at the ultimate load and the serviceability at the working load, sort of extension of the WSM and ULM. The acceptable, first we are going to see what is limit state. The acceptable limit of a safety and serviceability requirement before failure occur is called as a limit state. Already we have seen in working stress method and in ultimate load method, we have seen that in working stress method we are going to reduce the stresses of the material, but here in limit state method we are not going to reduce the stresses of material. Okay, so the design of a structure by this method will thus ensure that they will not reach to limit state and will not become unfit for the use for which they are intended. Limit states, there are two main limit states. First is the limit states of collapse and limit state of serviceability. So limit state of collapse means here we can see the flexure of the various structural elements. Okay, flexure means the bending, and then various torsion in that come in this collapse. And in serviceability you can say the deflection, crack width. These terms this include in this limit state of serviceability. LSM uses the multiple safety factors for the required safety and the serviceability at the ultimate load and the working load respectively. By considering the all limit state, these are called the partial safety factors. Like already I have told you that we are not going to reduce the stresses in the material in limit state method compared to the working stress method. Okay, but here we are going to use the certain partial safety factor for the materials in limit state method, and partial safety factors for the material and partial safety factor loads that we are going to see here in this limit state method. Clause 36.4.2 of IS456 state that for partial safety factor for material like concrete and steel, that the gamma m for the concrete and the steel, that is gamma m is a partial safety factor for steel, should be taken as 1.5, and for 1.5 for concrete and 1.15 for steel respectively when assessing the strength of the structure or the structural members employing the limit state of collapse. Okay, so when you are going to use the material like concrete and steel in the limit state method, the partial safety factor for material for concrete you are going to take as 1.5, and for steel it is 1.15. It is assumed that the concrete in the structures develops the strength of 0.67 times the characteristic strength of the cubes. Already you people are aware that characteristic strength of concrete means after 28 days whatever strength we are going to get from the cube, that is the characteristic strength. And generally it is assumed in a concrete the structure develops the strength of 0.67 times. Okay, accordingly in the calculation of the strength employing the limit state of collapse, the characteristic strength, that is FCK, is first multiplied with the 0.67 size effect and then divided by 1.5, that is gamma m for the concrete, to have 0.446 FCK as the maximum strength of concrete in the stress block. So we are going to use the strength for concrete after using this partial safety factor for material. Actually we are going to use 0.446 FCK as the strength of maximum strength of a concrete in the stress block. Design stress for steel Fy, that is yield stress of the steel, and gamma m. So Fy divided by 1.15. So we are going to use the strength as a 0.87 Fy in the design stress block. Various partial safety factor for loads. Now when we are going to deal with the limit state method, partial safety factor for material is different and partial safety factor for loads are different. Okay, so gamma f is here we are going to consider the partial safety factor loads, and values of partial safety factor for loads is given like this. It is based upon the load combinations, actual load coming on the structure, and we have to consider the combinations, and limit state of collapse and limit state of service. Already I have told you the limit state of collapse means it is considered as the flexure. Okay, limit state of flexure. So limit state of collapse means the flexure, torsion, shear. This kind of collapse is this types of failure is coming to limit state of collapse, and limit state of serviceability is nothing but the deflection, cracks. Okay, so for different type of load combination they have given the different types of the various types of values. So first you are going to see the combination dead load plus imposed load. So dead load plus imposed load in the limit state, the dead load partial safety factor for load 1.5, for imposed load it is 1.5, and for wind load it is 1. Okay, so for dead load plus wind load the factors is 1.5 or 0.9 and 1.5, and similarly and for dead load, imposed load and wind load 1.2, 1.2, 1.2 for the dead load, imposed load and wind load. And similarly in limit state of serviceability for short term effect for dead load and imposed load, that is factor is 1, 1, and for dead load and wind load this factor is again 1, 1, and for dead load, imposed load and wind load the factors are for dead load 1, for imposed load 0.8, and for wind load is 0.8. We have to take the note of the fall in from the above this table. While considering the earthquake effect, substitute the EL for the wind load. Okay, that is earthquake load in place of the wind load. For the limit state of serviceability here in this part, the values of gamma F given in the table are applicable for the short term effect, while assessing the long term effect due to creep and the dead load and that part of a live load likely to be permanent may only be considered. Next, we have to know the certain terms in this limit state method, that is characteristic load. What is meant by characteristic load? FCK. The characteristic value of the load are based upon the static data. It is assumed that in 95% cases, the characteristic load will not be exceeded during the life of the structure as shown in the figure here. This is characteristic load. Thus, the design of load are calculated as like this: FCK is equal to Fm plus K into rho. Here, this FCK, Fm is means load, FCK is characteristic load, and this rho is nothing but the standard deviation. Here you can see this value is Fm here, FCK here, and 1.64 is a rho, is this distance. Next, characteristic strength. Similarly, the characteristic strength of material as obtained from the statical approach, okay, is the strength of the material below which not more than 5% of the test results are expected to fall, as shown in figure like this here. Okay. However, such characteristic strength may be differ from sample to sample. Okay, so if you are going to consider the 3 cubes, so that characteristic strength is a differ, okay, from sample to sample of the cube. Thus, the design load are calculated as FCK is equal to Fm minus K into rho. So here the values of FCK, as you know, characteristic strength, and the value is mean strength, and the standard deviation is a rho. So last one important thing in a limit state is that already we have seen the 2 methods, that is working stress method and the ultimate load method. In that they have not taken the precautions, or they have not considered the limit state of serviceability. Okay, but in the limit state method, when we are going to increase the stresses in the material, what happens? The size of the member or the sections of the member is going to reduce, or the thickness, depth of the members is going to reduce compared to the WSM method. And ultimately, when the strength of the when the depth of the material, depth of the members is going to reduce, ultimately it attract the deflection and the cracks. So for that, in limit state have taken the care of that deflection and the cracks also. So first, now you are going to see what are the various clauses given to prevent or to check the control deflection in a limit state of serviceability. Clause 23.2 of IS456 stipulated the limiting deflection under 2 heads as given below. The maximum final deflection should not normally exceed span divided by 250. Okay, and the maximum deflection should not normally exceed lesser of span divided by 350 or 20 mm, including the effects of temperature, creep and shrinkage. Okay, so these effect including the effects of the temperature, creep and the shrinkage occurring after erection of the partition and the application of the finishes. So for control of deflection, the vertical deflection limit may generally be assumed to be satisfied provided that the span to depth ratio are not greater than the values obtained as below. So here basic values of span to effective depth ratio, span up to 10 meter. So when beam is a cantilever beam, that value should not be greater than 7. When beam is a simply supported beam, that value should not be greater than 20. And when beam is a continuous beam, that value should not be greater, that Ly by the span to depth ratio should not be greater than 26. Okay. Second here, modification factor for the span, okay, less than 10 meter. So you can use the modification factor to increase these values. How you are going to increase this value by using modification factor? The modification factor is that whatever the required steel, whatever the AST required or the area of steel required, if you are going to provide the extra till, that advantage you have to take. Okay, and as by using the IS456, this value you can increase by multiplying the modification factor. Okay, in cantilever beam, this modification not applicable as a deflection calculation have to be done. Okay, so the modification factor not going to apply for the cantilever type of beam, and multiply values of rho 1, these values you have to multiply by 10 divided the span in the meter. Okay. One minute. So modification factor depending on the area and stress of the steel. Multiplying the value of rho 1 or 2 with these values with the modification factor from the figure number 4 in IS456. Then modification factor depending upon the area of the compression steel also. Further multiply the earlier respective values with that obtained from the figure 5 of IS456, and modification factor for the flange beams, the modified values of rho 1 and rho 2 as figure number 6 of IS456. Further modify as per the row 3 and 4, where the reinforcement percentage to be used on the area section equal to width of the flange and the depth. So this is about the general preliminary information about what is limit state method, what are the various methods of design. Okay, so in detail we are going to see how we are going to use the limit state method, working stress method, and the ultimate load method. Okay, so we are going to stop here.